Hi, my name is Dr. Michael Batu and I'm back. And for this video, we're going to discuss equilibrium national income, but this time it's with government. So how do we introduce government into our model? Well, the way it works is like this. We will assume that government spends, and that government spending, we call that G. So let's say introducing government, okay? So we have government spending, we call that G. And we will assume that this G is constant. It's autonomous. So we call that G sub 0. So this G, this is government expenditures, and this is autonomous government expenditures. Now, if government spends resources, the government needs a way to collect these resources. And how does government do that? By way of taxes. So we're going to assume that government collects taxes. We call this tax T, which is equal to T times Y. Where small t, or sorry, not small t, big T, this is the tax revenue. Small t is the net tax rate. And Y is our national income. Taxes are collected by the government from the income of households in the economy. So which means that having taxes or having government in our model will impact our definition of disposable income. Let us recall disposable income. Disposable income, we call disposable income YD. If you remember from our previous videos, we refer to YD as disposable income. This is simply equal to Y. Remember from last time, we assumed that YD equals Y. But with government spending or with government, it's not the case anymore, because it will be the difference between income or national income and the tax revenue collected by the government. So that's how it's written. So now our YD becomes Y minus T, and our T is given by this big guy. This T equals, so big T equals small t times Y. So how would this impact the equations that we had earlier in the case where there was no government? So let's write them down. So recall the consumption function as follows. So remember, consumption function is C equals C sub 0 plus B YD. Now our YD is, it's not just Y, unlike earlier. Now it's Y minus T. So we sub that in. So we have C sub 0 plus B Y minus big T. C equals C sub 0 plus B. We know that this big T is equal to this guy. So it's going to be Y minus small t times Y, or this guy, factor out the Y, 1 minus T times Y. And this is our consumption function. Okay. Now, how would the addition or the inclusion of government affect our definition of aggregate expenditure? Well, remember that aggregate expenditure is equal to C plus I in the previous video. So AE is equal to C plus I, but now we have government, so we're going to assume that this is or that our AE includes G. So it's not just C and I, now you have G. So it's C plus I plus G. From our previous video, so I'm just going to write it here. Recall from previous video the following. That we assume that I equals I sub 0. So we're going to include that here. And using our definition of the consumption function with government, now we have the following. So AE equals C sub 0 plus B 1 minus T times Y plus I sub 0, because of our assumption from here. And we assume that G equals G sub 0. Okay. Let's collect terms. So we have AE equals to C plus I plus G. Note all the terms with a subscript 0 or O's. right there. These are all autonomous expenditures, plus B 1 minus T times Y. So let me just encircle this. All of this, these are the autonomous expenditures. This guy right here, B times 1 minus T, it's the marginal propensity to spend. Okay. Now, in the next part of this video, what I'm going to do is we're going to graph our AE and we're going to solve for the equilibrium national income when government is present in the model. All right, so what I did here was to rewrite all the equations that we will need to construct the graph that would give us the equilibrium national income and equilibrium aggregate expenditure. So we have here our aggregate consumption function with government. So you see there's a T over there. I equals I sub 0, we've assumed this. G equals G sub 0, we also assume this. And we have our expression for aggregate expenditure, which we had previously. All right, so what we're going to do is the following. We're going to graph everything here. So first, we're going to graph I sub 0 and G sub 0. Or better yet, I'm just going to graph AE. And then once I move on with the numerical example, then I will also graph this one. The reason is that I didn't make any assumption on which one is bigger. Okay, but it doesn't really matter for now. What I'm going to plot is I'm going to plot this guy. So let's start. So we know that our T, so we're going to assume that T, or small t, is between 0 and 1. Okay, that way the slope of our aggregate expenditure function is upward sloping. So it slopes upward. All right, so this guy, this is our AE. And our autonomous expenditures would be at here. C sub 0 plus I sub 0 plus G sub 0. Now, how do we find the equilibrium aggregate expenditure and equilibrium national income? Well, the equilibrium condition is the following. So in equilibrium, Y equals AE. So Y equals AE can be shown by way of a 45-degree line. So we're going to have a 45-degree line here. And in this 45-degree line, Y equals AE. Okay. So what we're looking for is this. We're looking for the value of Y that gives us the intersection of the 45-degree line and our AE function. So we don't know what this is. And also this guy right here. We don't know what this is. Okay. So using algebra, we're going to come up with an expression for equilibrium national income. So let's do that here. So we know that Y equals AE. So we simply sub in Y over here. So we get Y equals C plus I plus G plus B 1 minus T times Y. We move this guy to the left-hand side. So Y B 1 minus T times Y is equal to C plus I plus G, all with subscript of zeros. Factor out the Y. So we have 1 minus B 1 minus T is equal to C plus I plus G. And finally, we have Y star, which is equal to 1 over 1 minus B 1 minus T times C plus I plus G. So using algebra, this is the expression that gives us the equilibrium national income. So that is our Y star over here. So let me just write that again. So this is our Y star. And we know in equilibrium Y equals AE, then this guy is also our AE star. So in the next video, what we're going to do is we're going to have numbers, and then we're going to solve this equilibrium values numerically. So I'll see you in the next video.